Hi, welcome to Designing a Database. In this video, I'm going to cover the essentials regarding what you might encounter when you undergo the task of creating a database for the first time. This section is probably going to be more useful for those who are building a database, but it might also be good for end users who would like to understand the foundation on which their database was built. In order to explain how to design a database, I'm first going to show you how not to design a Microsoft Access database. And I know that might seem a little backwards of a way of explaining the material, but trust me, this is the easiest way to understand exactly why we are structuring tables the way we are once we get to that portion of the class. So, after covering the how-nots, I'll show you some of the how-tos, which of course will lead us into a little something called normalization. Now, I should tell you right off the bat, we're not going to get too heavily into normalization. People spend entire academic semesters studying normalization, and others dedicate their careers to it. You and I'm pretty sure, are not these people. So this is meant to be more of a basic overview. After that, we are going to start working with our scenario. A small literary press called Picaroon Publishing needs a database, and we're going to be building one for them. But before we jump into Access and start building them a database, we're going to need to create a plan for building that database. And at the end of this video, we're going to create that plan. So let's go ahead and get started. Starting from scratch can be quite a daunting task, given all the information that you'll have to organize, like employee information, customer information, orders. There's just a ton of data. So I'm going to break it down for you with a very simple example. Let's say I'm starting my own cookie company and would like to keep track of some of the information that would go on an invoice. I might structure my table something like this, with an order ID, customer name, address, phone, cookie ID, price, quantity, and total as my fields. Now, I have a lot of experience in Excel, so let's say I just think, well, maybe an Access table should be structured kind of like an Excel spreadsheet. Notice how all of these are arranged and all the data goes. Now, this might be okay for the first few orders, but once your database goes, this structure becomes quite problematic. So let's play this out. So let's say my grandmother calls me up to place an order. Hey, Heather, how's it going? She's from Tennessee, by the way. I'd like to order some of your cookies. Well, that's great, Grandma. Okay, so I'll take down her order number. She's order number ID number 1. And her name, Grandma Enos. I'll also take down her address, her phone number. What kind of cookies would you like, Grandma? Oh, Heather, you know me. I'm a big fan of chocolate. What kind of chocolate do you have? Well, I've got chocolate chip. Okay, that'll be just fine. So I write down my own little cookie ID for chocolate chip cookies, CC. And that'll be $2.99 per box. How many would you like to order? Well, Heather, you know I'm on a fixed budget. How's 2 sound? Well, that sounds great, Grandma. So I write down 2, and her total comes to $5.98 before tax. Now, let's say my other grandma hears that I've started my own cookie company and that my other grandmother beat me to the punch of the order. So now she's got to call and place an order because the other grandma did. So Grandmother Von Dorn, that's my maiden name, she calls me up, places an order. I take down her order ID, her customer name, her address, her phone number, and of course, now my other grandmother's a huge fan of peanut butter. I think I once caught her on eating right out of the jar with her fingers. Ew. Price, same thing, $2.99. She orders 5 boxes, so that brings that total to $14.95 before tax. So with these 2 orders, so far everything in my database is going pretty good, no problems yet. But let's say Grandma Enos down in Manchester, Tennessee has some boys from the neighborhood stop by and they mow her lawn. And she's old, she doesn't carry a whole lot of cash anymore, so she pays them in, well, boxes of my cookies because she just thinks they're that good. So she gives them both away, and now she doesn't have any cookies for herself. So she's got to call me up and order one more time. Now notice what I have to do. Even though it's a new order, I have to take down her customer name again, her address again, her phone number again, and then the rest of the information that's unique. Now, the problem with structuring this, on just a customer service standpoint, I mean, you can imagine every single time I'm on the phone taking an order, I have to ask them for all the information that I already have somewhere else in my database. Now, that's not really good. If you've ever called a location and they ask you those 20 questions that they always ask, what's your address, what's your phone number, what's your favorite color, you get kind of annoyed because you know that they already have that info. From a computer database standpoint, it takes up a lot of space. All of this repeating information, every single character takes up room somewhere. But also, in addition to this repeating data, notice we have the potential for error. Every single time someone is manually having to enter in information, they're going to make a mistake typing. I think the recent studies show that even expert typists will make a mistake typing every 3 minutes. So imagine someone whose job it is to do data entry. They're going to make mistakes. So you want to be sure that they're having to type in information as few times as possible. So this table, if you notice, this is the only unique information, the order ID, quantity, and that total. And really, that's the only thing that you should be keeping track of in a kind of orders table. The rest of this information, anything that repeats, you want to take out of this table and place in a table all by itself. And that's why we do not structure data in one big table like this. Avoid it as much as possible. So what we would do is follow a process called normalization. Now, normalization is the process of breaking down and organizing data in order to save space, eliminate data redundancy, data inconsistency, and data redundancy. Oops. Yeah, these are the jokes, people. So here's what our tables would look like. We have a customers table, an orders table, and a cookies table. General rule of thumb, when you're building tables, you want to make sure that every single table contains information for just one topic. So it's kind of like similar to writing. When you're writing a paragraph, in that one paragraph, you should keep it to one topic. So with this, every bit of our information that pertains to customers should go in a customers table. Likewise, any information that's specific to an order, that goes in an orders table. And information regarding our products, or in this case our cookies, that's going to go in its own cookie table. So this is what our tables would look like. But how will Access know who ordered what? Based on what we see so far, there's really no way to relate these three tables of information together. Well, this is where keys and relationships become very important. What we do to solve this in our orders table, all we have to do is add 2 more fields, which are the primary keys from the other tables, and then create a relationship from customer ID to customer ID, from cookie ID to cookie ID, and that's going to join everything together. Those 2 fields that we've added to TBL orders is what we refer to, by the way, as a foreign key. So once again, primary key, again, that's the unique identifier for a table. And a foreign key is a field in one table that relates information to another table, and usually that's going to be through that primary key. Now, that was just my basic overview of why we normalize. In a minute, I'm going to go more in depth and cover what database admins refer to as normal forms. But before we do that, I'm going to offer a bit of a disclaimer. Like anything academic or theoretical, there's always going to be some disagreements and some inconsistencies about how to go about doing or even understanding something. For example, if you were to get 3 database administrators in a room, they'll have 8 different opinions between them. So even if you were to go online and just spend a day reading up on normalization, every single source you'll find will have a slightly different opinion or explanation on what even constitutes, let's say, the first normal form. What I'm offering here is a kind of loose compromise between these differing opinions. I don't intend for you to walk away from this thinking this is what you have to follow or even agree with. This is just a general overview to point you in the right direction and to give you a basis for further research. With that said, I bring you to the basic normal forms. Some people like to think of this process as steps into how much to break apart their data, again, all in the name of saving space and enforcing data integrity. At normalization's most basic level, you have what's known as the first normal form. Most of the time, when you're designing tables in Microsoft Access, you're going to be trying to follow at least the first normal form. A table is considered to be in what we call first normal form if all fields represent the smallest meaningful value, you have no repeating groups, and that table contains at least one primary key. In order to be classified as following the second normal form, first a table must be classified as being first normal form. It has to follow all of those previous steps in order to begin to talk about or building it into second normal form. Also, in addition to the rules for the first normal form, all fields must describe the primary key where you don't have any partial dependencies. If you find that you have fields that do not describe the primary key, the first step into fixing that is to move those other fields to another table. After that, we have what we call the third normal form. To be classified as following the third normal form, a table first must be in first normal form and second normal form and follow all that criteria. And with the third normal form, there are no non-key fields that depend on a field that is not the primary key. Now I'm going to break this down and give you examples of each to make this a little bit more concrete to understand. The easiest rule to start with for the first normal form is the rule that states that tables contain a primary key. This rule is the easier rule to follow in Access, mainly because Access has a lot of built-in warnings and message boxes that will constantly pop up to remind you to create a primary key. Inside your tables, all that primary key really does is ensure that Access has some way to uniquely identify records and relate those records to other records. The second rule for the first normal form states that fields or attributes are broken into the smallest meaningful value. Now, to demonstrate this rule, let's go back to the cookie database I showed you earlier. Now, this table is structured slightly different in order to illustrate my point. This table does follow the first rule. We have the order ID designated as our primary key, and we have 3 additional fields: transaction date, customer, and cookie. The problem with this is that our customer field, in addition to our cookie field, is lumping together different aspects or kinds of information. If we wanted to, let's say, filter or sort our data by last name, well, we'd have a problem doing that because, well, the first name and last name is lumped together. Likewise, if we ever wanted to cross-reference our cookies purchased by customers, we'd have to parse this data in these fields to determine which cookies were ordered by which customers. To get around this problem, some might end up structuring their table something like this. We've broken apart the customer field into a first name and last name field and broken up our cookie field into 4 separate fields. This fixes the immediate problem and places data in its smallest form. We can now search for order by last name. However, this structure creates yet another problem: the potential for null values. Now, all null means is a blank in your database. I'll explain this when we get into our queries section. However, just know for now that you want to avoid the potential for null values in your database. This leads us into the third part of the first normal form, the no repeating groups part. Now we've got cookie 1 and cookie 2. This is essentially the same group that is repeating over and over again, which does limit our database to, well, one customer can only order 2 different cookies. Well, that's not necessarily the case. So we want to figure out a way to structure our table to avoid these repeating groups: the cookie 1, cookie 2, quantity 1, quantity 2. So what we can do is create a table that looks something like this, where we have order ID, customer name, last name, cookie ID, and quantity. This structure forces every single time a customer orders a different product that they have to be given a new order ID for that new product. Now, if you look down below, order ID 3 and 4, that's essentially my third order in my database, where Grandma Enos called me up and asked me to order 2 different kinds of cookies: chocolate chip and peanut butter. But in my database, because I have to have it broken apart by its unique identifier, the only way to do that is by creating two separate order numbers or order IDs. And that fixes the immediate problem of repeating groups, but creates an entirely different problem. Now, I've seen a lot of databases that use this structure for their orders, and they love it. They think it's just fine. They just know that, well, one order ID could represent one customer calling and placing one order. It's just that they break it down a little bit differently than how you would expect it. And that essentially is all that makes up your first normal form. In Access, if you look down here, all tables in Access should be in the first normal form. It's not absolutely necessary. I have seen some people who are able to get away with no normalization whatsoever, but their uses and purposes for building an Access database are very, very small. If you plan on relating information from one table to another, to use a query to pull information together, to filter, to sort, you will have to at least follow this first normal form if you want Access to, well, be friendly. Now, the problem that we created earlier with the first normal form, this is where we get into the rules that make up our second normal form. That states all fields must describe the primary key where you have no partial dependencies. If that is the case, if you have fields that do not describe the primary key, you move those fields into another table. And to illustrate that, let's go into a more concrete example for the second normal form. First off, your table must follow all criteria for the first normal form. So let's go back to where we left off with our cookie table. Now, we're going to add the criteria that all fields must describe the primary key. In other words, there shouldn't be any partial dependencies. Now, technically, very few of these fields really describe the order ID. And that brings me back to the three-table structure I showed you earlier, where then we go through and break up this table according to topic, where we have all of our customer information stored in our customers table, all of our cookie information stored in our cookies table, and everything that's left over gets stored in our orders table. To link information from the orders to the customers and from orders to the cookie table, we add the two foreign keys in order to connect these records. So here is what our orders table will look like after we fix that structure. Order ID is still our primary key. Transaction date does describe when the order took place. And customer ID and cookie ID now act as foreign keys linking information stored here to information stored in the customer and cookies tables. If we wanted to get really, really nitpicky, technically, quantity does not directly depend on the order ID, and for that matter, neither do cust ID and cookie ID. And some professionals will say, well, that means that we should move those fields out and put them in a different table. That's where we get into our rules for the third normal form that state that no non-key fields depend on a field that is not a primary key. To illustrate that, let's go back and continue to dissect our current orders table. Down below, if you remember the problem that was created after our first normal form, where if a customer calls to place an order for two different products, or cookies in this case, we had to list that order as two different order IDs in the name of keeping each field in its smallest meaningful value. To follow the third normal form, if we go through and examine these field dependencies, our transaction date does depend on the order. This field is fine where it is. Customer ID could also be said to depend on what was ordered, that particular order. Again, some might argue with this, but for our purposes, this field depends on the order. Where the problem really begins to arise are with the two remaining fields. Cookie ID could be said to depend upon the date, as quantity depends upon the cookie that was ordered. Following our third normal form rule, no non-key fields depend on a field that is the primary key. So we need to go through and remove these fields. So here is what our new structure or modified structure will look like. We still have TBL customers off to the left that holds all of our customer information. And we still have our cookies table all the way off to the right that holds all of our cookie information. But our orders information, we could split up into two separate tables. Our primary orders table lists that unique order ID as well as that transaction date. Also, the customer ID is used to track back information to the customers. Then we create a secondary table, TBL order details, that stores that specific information. We would have, rather than have one primary key, we would have two fields act as the primary key, where not one, but both fields act as the unique identifier for the table. So the combination of the order and cookie, that combination will be unique, where the order ID will be allowed to repeat. So we could have order one, order one, order one, but three different cookies in combination with that order. And that would allow one customer to order multiple products. Then, in addition to each one, we would then list the quantity next to that cookie. So if you wanted to see what TBL orders and TBL order details would look like in datasheet view, here they both are and how they relate to each other. Our orders table up above, those are the order IDs, again, only the unique information for that order. Then down below, the combination of the order ID and cookie ID acts as the unique identifier. That allows us to have that order ID repeat, but the cookie be different. Now, this particular example for the third normal form, we will be using in our database a little bit later. So I'm going to go through and explain what all this structure means in terms of terminology, relationships, and whatnot. That I will go into a lot more depth a little bit later when we start working with our scenario. There are other rules and other normal forms that you can follow. There is the Borscod normal form, which states every determinant could be a primary key. I've also heard a clever little statement that they've come up with that states the key, the whole key, and nothing but the key, so help me God. Now, I've heard that little statement so many different times, but Claire Churcher in Beginning Database Design from Novice to Professional credits a guy named Bill Kent for that cute little slogan. And again, this simple quotation basically just kind of helps you make sure that all of your tables are normalized to the third normal form. There is also a fourth and fifth normal form. Now, I'm not going to go into those in this video. That's a little bit more complex for a beginner and intermediate video. And for access, chances are you won't ever have to move beyond the normal forms that I've addressed here. So, with that said, here's the bottom line. At some point, you're going to ask yourself the question, how far should I normalize my tables? And, well, the answer is simple. It depends on your sorting and grouping needs. For some tables in your database, yeah, you're going to follow the first normal form, maybe the second normal form. And other tables, you're going to take the full, 4 or 5 yards. It really depends on your purposes. For example, a mail carrier might need everything in an address table fully normalized in order to sort and group. However, do you really need to have a zip code field that looks up cities and states? Probably not. So again, the bottom line is depending on what forms and what reports you plan on creating, that will determine how far you go into normalization. So, when you are getting ready to design a database, here are some of the basic steps you should follow first. Number 1, do a basic needs analysis. Whoever it is you might be designing this database for, talk with them, figure out what the primary goal is for the database. Find out who's going to be using the database, who's going to be doing the data entry, who's going to be doing the data analysis. Find their original data. How is their original system structured? How is their existing system affected? What about this system is limiting? And then from there, figure out what tasks should users be able to perform with your database. After that needs analysis, go through and examine all of their existing data and reports. How is the data defined? How are the reports structured? Are fields consistent throughout each report? If not, how can you make them consistent? Then go through, aside from Access, this is working on pen and paper, create a grand master list of all of your existing data, all of your existing fields that you're going to start arranging and trying to break up into different tables. Then start creating your table structure. It's a puzzle. Figure out where you're going to place what, normalize your data, plan for relationships, then go through and create your tables on paper first. Then you start planning for data input. And again, all of these steps, this is before you even open up Access to start creating a database. There's a lot of legwork that needs to happen before you even touch a computer. These 5 steps, this can take anywhere from, let's say you're creating a database just for yourself or maybe for one person, that could take maybe a couple of days. If you're creating a database for an entire company, well, yeah, that's going to take months and months and months just to learn their system, to try to figure out what it is they do, what they're going to use for it, and what's going to work best for them. The more time you put into these initial steps, the easier it is for you to actually create a database when you're ready. So with that in mind, let's learn a little something about the company we'll be building a database for throughout this course. So welcome to Picaroon Publishing. Just to give you a little company overview, Picaroon Publishing began in February 2006 with 5 employees who were frustrated by the constraints and politics behind large corporate publishing houses. They sought to build a small literary press that wasn't focused too heavily on profit margins and instead focused on building a better place to make literary art shine. Picaroon's goal was, and still is, to find new authors who aren't afraid to experiment with contemporary literary trends. They had very few expectations for the company, a quarterly literary magazine, a couple of novels a year, etc. And at first, managing their respective projects, orders, and employees was fairly manageable with so few people and with very few sales. However, within a year, as word spread about this rogue press, submissions increased, sales increased, and the need for more help was very apparent. As more and more employees were hired to balance some of the managerial and editorial burden, they soon discovered their record-keeping ability proved subpar, to say the least, and needed to be standardized. Our task is to take their existing data and build a simple database for Picaroon to manage. Now, we conducted our needs assessment and we've spoken to a variety of different people from the company. And based on our survey, this is a brief summary of what we've learned. Here's the problem. Since this was a small press originally started on a small budget, the task of record keeping for employees, authors, or projects was just assigned to whomever had the time, a task that often was juggled from person to person. Because of this inconsistency, data was kept in a variety of different forms. Some kept records in Microsoft Excel, while others kept records in Microsoft Word. Their orders for right now live in an online shopping cart, which a private distributor manages. The only way for the small press to view sales information is to export information as a CSV file. However, the private firm that manages the system and fulfillment has just raised their prices by 30%, which is just too much for the small press to reasonably afford. So, in an effort to save money, they would like to move this data over to Access and manage their sales and fulfillment themselves. So based on our needs assessment, we've identified these major goals. They want to keep track of employee information, author information, customer information, sales information, and yes, shipping information. Now, these first 4 goals, I've got to say, are a little easier to manage inside Access. But the last one, that shipping information, that could get a little complicated depending on how they decide to ship. If they work with a kind of a flat rate, then our tables are very, very simple. It's just adding one field to our sales table. However, if they plan on basing the shipping rate on the weight of the package and the region they're shipping to, well, that could be, if you saw from our normalization section, that could mean adding up to 5 different tables just to store and manage that information. Now, based on our original assessment, Picaroon, because they really haven't decided how they want to handle shipping, they're still working on that. They're researching prices, they're researching different carriers, and they're going to get back to us about that one. So for right now, we are going to assume that they want just a simple flat rate shipping. If they decide a little bit later that they want to get a little bit more complicated, then we'll have to rearrange or restructure our tables based on whatever carrier they choose. So once we've established their primary goals for their database, now it's time to move on and actually look at their existing data. And they've mailed to us several of their Microsoft files from Access, Word, and their CSV files that this just basically was a simple export from their shopping cart for us to look at their data and kind of get an idea of how to structure data in Microsoft Access. So to do that, let's go ahead and open up these files. So I'm just going to minimize OneNote and navigate to wherever that exercise file is stored on. I put mine on my desktop. And we're going to the folder number 5, Designing a Database. And here are their various files. We have, it looks like, a Word template, and it says invoice, so I can only assume it's an invoice. I'm just going to go ahead and open that up. And again, since it is a template, it's creating a brand new document based off of a standardized template. And zooming out, this looks like something that they would hand to customers. And based on what I see here, we've got a table, it looks like, where they would have to type in all of this information themselves. Every single time a customer places an order, they have to manually type in the address. That would probably take quite a while. They'd also have to look up every single time their customer ID. The book that they've ordered, they also list that by book ID, which I could assume would be some kind of maybe ISBN number. They type out the book title, the quantity that was ordered, retail price, and then they have to calculate the total themselves. Down below, they have a subtotal of all of the products ordered. Their shipping rate goes in here, and the basic order total, grand total for everything above. So that is what they basically want to be able to create on their own via Access. So we have to make sure we accommodate all of these individual fields: the book ID, book title, quantity, retail price, total. We also have to consider the look of this invoice. They've personally told us that they don't want their invoice to change. This is like a shipping slip. They want it to look exactly like this, which in Microsoft Access is a fairly simple task. And when we get to our report section, we're going to be recreating this one only in Access. So that's our first invoice. We kind of have an ID. We'll kind of make a little mental note of the fields here. Let's look at some of the other ones. I'm going to go ahead, close Word, and back to our folder. Let's look at some of this order information. Here's our text file, sample order information. Got to open that up. And here's your comma delimited file. It's a little bit hard to read, but you can kind of see at the very top row here, we have all of the field names. They've got fields like order ID, customer ID, which it looks like it repeats in this one. Company, contact first name and last name. That's interesting. They're keeping track of the person from the company that they do all their correspondence with. So we'll have to keep that in mind when building our tables. Standard address information, one address field, city, state, zip code, transaction date, and it looks like in this is simple date time format. We also have a book ID, which looks like pretty much just a simple number. It probably is not an ISBN number. Okay, it's just a very simple number. Book title. Oh, look here. We've got the individual. Here's their quarterly that they publish. Volume 1, Issue 3. Romance Canyon. That looks like some kind of a novel. No issue numbers after it. Okay. And scrolling to the right, we've got quantity of what was purchased, retail price, which they also keep track of, also repeats. Shipping weight. Oh, they do have a shipping weight field of how much that book actually weighs. And a subtotal field. Okay, interesting. So we'll have to keep this in mind when, all these fields in mind, when we are building our tables. Go ahead, close that. And if you have trouble viewing that text document, and if you want to see it in a simpler form, I've included the Excel file of the exact same information. You can see that here. It's just a little bit neater, and you can import that fairly easily from Excel. Now, the last document that they've handed us is the employee author list. Now, this is an Excel file. Go ahead, open that up. And looks like we have 3 tabs down below. We've got an employee list, an author list, and a customer list. Now, let's focus in on the employee list. All right, we have an employee number, which doesn't look like a meaningful number to me, but what's going to really matter here is this employee ID. Okay, looks like it's not a social security number, but they do have a format applied to it. You can see the data that's actually stored. This is a format with those dashes plugged in. We have a first name. They also keep track of middle initial. Last name, job titles, accounting assistant, office coordinator, managing editor, writers. They also keep track of what department those individual employees work in, their office extensions, and their company email address. What I don't see is information that tells me where the employee actually lives. So either they don't plan on storing it in this database, or they just haven't given it to us yet. So that might be something we wanted to ask them if they wanted to include that in this database. Now, down below in authors, looking at this, they keep their authors in a separate area, and the format looks fairly similar to the format of the employee list, only they do keep track of the author's address and phone number, but it doesn't look like they keep track of the author's email. They have an author ID, which I'm not sure. They might have some system for it, but we can accommodate these fairly easily just by creating a number field for our table. Next, we've got a first name, middle initial, last name, street address, city, state, and it doesn't look like they have any authors from other countries, so that actually makes it a lot easier on our part when we're designing our tables. We have a zip code, and they don't have the last 4 digits included, so that we can make optional for when we're designing our tables. They have a phone number field, and based on the format that they have here, if you look at how it's stored up top, all of this is again a format that's applied over it. Book title. Now this is interesting. They don't distinguish between their quarterly book and their individual books. So we have issue numbers, which anything that's a book and not published in their quarterly mag, we've got null values or blank fields here. Now we can copy that style in our database fairly easily, or we could try to improve the structure. So we're going to have to decide what we want to do with that when we start figuring out how to put all this data into our tables. Ooh, they also keep track of what genre, and I'm sure that's more for their quarterly than anything else, but what we have here, we've got, okay, poetry, fiction, poetry. They've got multiple values in a field. They've got autobiography, which is they also classify as nonfiction, textbook, comma, nonfiction. We're going to have to figure out a way to accommodate multiple values for a genre for any given book. We'll keep that in mind. And with that author information, again, keep a mental note of all of the fields here. Let's move over to customers. Customer information, again, they have a number, and I just assume that they just wanted to keep a record of how many they have. Customer ID, they do assign their customers an ID. Company that they're with, and it doesn't look like they have any blanks here. It looks like they mainly sell to bookstores and newsstands. Contact first name, last name, address, city, state. Again, nothing in Canada or any foreign countries here, so that actually makes our job a lot easier. Zip code and phone number. But I don't see any credit card information or anything, so that I imagine their distributor handles that right now. We'll have to ask them if they want to include that in their database or not. Okay, with all of our information, now it's just a matter of figuring out how to structure this one. So here's our grand master list of every single field that we saw from their existing data. And this is, again, just for us, just to kind of keep track of the things that they kept track of. And based on conversations we've had with them, they've gone through and suggested adding a couple of more fields to keep track of some other things they'd like to keep track of. So here, we've added the resume field. They said the Human Resource Department has a whole big stack of resumes, and we mentioned that it is possible for us to take those Word files and store it in their database, just to kind of help them keep track of it. So we're going to include that field here. And all things considered, this isn't a whole lot of data. It could be a lot worse, but since they're a small company, this is probably more manageable than a lot of tasks that you'll undertake. But even though it's not a lot of different fields, it can still feel a bit overwhelming looking at all of this and going, okay, where am I going to put it? So usually it's best just to focus in on a portion of the data at a time, usually going back to that topic. Focus in on one Excel sheet. If they've logically ordered it according to employees, start with that information and figure out how you would structure just that information. So we're just going to focus in on some of our employee information off to the left and try to figure out again how to structure tables. Is it going to be one big table or a series of several tables? Now, what works for me when I'm trying to figure out about how to arrange data is usually from that big list, I will then go through, cut out all of the individual fields and rearrange them on a flat surface, just so I can visualize it a little bit better. So here's all of my employee information that we're going to focus in on, ignoring everything else because I don't want to feel overwhelmed. And here's how I could go through and rearrange things. Well, first of all, I need my unique identifier employee ID, then follow that up with first name, middle initial, and last name. Then maybe move all of my company information like job title, email, office extension, and department to another table. And then that human resource information that's left over, the salary, benefits, and resume, that could go in a third table all by itself. So looking at this kind of three-group structure, I would have to add two more fields, probably that employee ID to the top of that job title and to the top of salary, so I'd have three separate tables. Now that's one way I could arrange this information. Or since my employee table, employee ID, first name, middle initial, last name, that's relatively small. And since I'm not keeping track of their home address or home phone numbers, I can move the job title, email, office extension, the rest of that company information to the employees table. So if I did that, here's what that one table would look like, all of those fields put together. And then the only thing I'd have to add would be the employee ID to my other kind of human resource table and then I would relate these two tables together through that employee ID. However, moving all of those other fields to one big table off to the left will create another problem. That job title, since more than one employee in my company will share the same job title, and since more than one employee is going to work in any given department, those two fields have the potential to repeat in this table. So if I want to, again, go back and following those rules of normalization to eliminate data redundancy, I should probably at least take out job title and that department field and move those over to a separate table. So really, how I could structure all of my employee data looks a lot like this, where I'll have an employee table off to the left-hand side, keeping track of the employee ID, first name, middle initial, last name, office extension and email, and then add a foreign key, the employee info underscore ID, that connects information in the original employee table to a kind of subtable, employee info, to hold the job title and the department ID, which again is a foreign key that links information to the departments table, which will then store all of my unique department information. My HR data, just to add, a few more fields to play around with. I've got that employee ID field. I can keep track of salary, hours. Notice I have benefits now. If I have the benefit ID, well, they have many benefits they could elect to. There's health, there's dental, vision, company offers the works. If I wanted to keep track of those different benefits that they could elect to, I can maybe even keep another table to store those different benefits. Then, of course, there's the hire date and that resume field they asked us to include because the human resource department just wanted some place to stick their resumes. But the bottom line is there are a lot of different ways you can structure these tables, and really that's one decision that you're just going to have to make. Going back to those rules of normalization, how far do you want to normalize your tables? Yeah, I could break my tables up, a few more steps, or I could combine them all into one big massive table. But I think this structure, separating the employee information into 5 different tables, is probably going to work best for the data that I have. And again, when we start building our tables, you'll begin to see that a little bit more. So with that in mind, everything we just did for our employee data, we'd have to repeat for every other category of data. Now this is a long and complex process that you'll probably go back and forth on as you build your database. And just to give you a sneak peek at what we'll be building in Access, there it is. There's all of our data broken up into a lot of different tables. Up top in this top row of tables, you can see that's all of the employee tables that we built earlier. And down below, you can see the network of tables connecting everything from author information to books to orders, different genres, etc. Notice how none of that, there's any direct connection to our employees tables that we created up top. And that's mainly because as of right now, our existing data that the company gave us doesn't have any way to link that information together. If they wanted to build a way, maybe they wanted to assign a particular employee to a particular book, well, we could add that in very, very simply later on. But for right now, this is our initial plan, which again probably will change, but for right now this is our plan on what we will be building in Access. And that's that for designing a database. To recap some of the terms covered in this video, normalization is the process of breaking down data in order to save space, eliminate data redundancy, and data inconsistency. Relationship is the means by which Access brings information back together through the use of common fields or information. Or as Coach, another instructor here at Train Signal, likes to say, it's the way you match stuff up. Primary key is a unique identifier for each record in a table. Foreign key, on a similar note, is a field in one table that matches up or relates information to another table. Normal forms are simply the standards for relational database design that include the first normal form, second normal form, third normal form, the Boyce-Codd normal form, and of course the fourth and fifth normal forms. For a good general overview, you can visit William Kent's website at www.bkent.net/doc/simple5.htm. He goes through and gives a brief explanation of each one of these normal forms on the website and in his book. And I'd just like to close this video with a simple reminder. Normalization is a puzzle. Have fun with it and go nuts. I'll see you in the next video.